Hello guys, what's up? For this session I'll show you step by step how you can be able to model this shape form, this paraboloid elliptic form. This here I'll show you how you can paraboloid the hyperbolic paraboloid form in using AutoCAD 3D and export it to robust analysis. So I begin quickly and change unity. I'll working in meters, unity to be quickly. Yeah, met, yeah, precision 2.0. Okay. After always to begin by create line 0 and 0, and I put 10 meters, and I change. I put 20 meters and 10 meters. Okay, I select. Here I put 10 meters and I select this. I put 10 meters. The total of length is 13 meter, and I will change the form of my arc, and I will proceed to move this from this. It will be for how many times? I'm gonna change. I put an offset of 5 meter, and here I put a move little bit 5 meter, and connect this line. And after I make move here, I move little bit for 2.5 meter, and this for move 2.5 meter. Okay. After I'm gonna change my UCS. Okay, and I gonna scale a little bit, a copy here to 2 meters, and connect 2 meters, and here I copy -2. Oh, not minus, just put 2, and this I copy 4. So I begin to create my arc with 3 points here. I begin here, and here. The second arc I begin here, and here. The third arc I begin here, and here. So I have 2 arcs. I delete. It's not needed. All this line. So from this line, these 3 lines, I change my templates for 3D modeling. So I'm gonna select it all and going quickly to surface and create loft. Git. I can do the same. I can go loft from this and this. It can give me this from. So I can just put little bit a copy here for scale 1 meters. Okay, so I'll talk you for the next why I did this. I'm going here and here, loft, and from here to here, loft. So I have this for, oh, sorry. I'm going here to here, I create loft, and here, loft. So I click enter. I don't need to create the just cross section only. Okay, I have this form directly, and as you can see, when I'm going to conceptual, you see I'm created quickly my form. And so when I finish to create my form quickly, I'm gonna change my generatrice and directrice here, the isoline and the view isoline. Here I put 13 SF 18 meters 18 meters, and I put here a 80. What we see, I put 12, and I see what it looks like. If it meets my needed from the shape form, I can let this form like this and export it from to robot structure analysis. By the way, I have another idea. I can add the columns and so, but I didn't do this. Then what I can do for the next? What I can do for the next is to see if it's suitable for me to let this form like this, so I can do it. Okay, no problem. So I let this form like this, and after I'm gonna create a shape. I select all my form and create a mesh. I'm going here and I click here. I have a mesh. When I have a mesh, so I'm gonna create a new layer. I create a new layer. I'm going to home and create a new layer. One layer. I can just put surface. Okay, and I change the form. Okay, I put red. I select it. I assign my new layer. After I hide the form and I delete this, it doesn't exist. And okay, my shape is ready for analysis. So before to export the model to robot structural analysis, this is shape form, I'm going to create explodes. So my form is ready, and what name? The demo August. Okay, so I open my robot. I save this model and I create a new shell form, and I'm going here, open, and where is the name? Demo Augusta. Okay, so I have my form. I click OK. When I finish to having my form, so I'm going to a preference materials. I'm working with hero code, and so, and I can see from my panel fitness, I'm going to the same template. So I can just select all and going to this form, object lists, apply, select this, copy, Ctrl V, paste, reinforcement concrete shell, thickness this 15, and model of calculation shell. I click add, and I'll be wait for a little bit, but it can taking time. It's depending of the type of your computer you use and the graphic graphic you use. Me, I'm working with NVIDIA RTX, so it can be quick fastly to make this iteration to give us the total shape of our shell. So already done. This is our shape, this is our form. As you can see, this model is able now to be analyzed in robot analysis. But if we begin in a robot to do this, if we did this model to robot, it can taking much several times. So AutoCAD, it helps us give us some typical tips, fast to model easily a complex form, 3D model, and make some parameter and export it to robot structural analysis. So because we are working in concurrent structure design, I'm talking about the shell structure form for the next session. So what I can do, I'm going to do the same things I did for our previous tutorial videos. So I'm going to click here and click to member and define member. When I click here, it recognizes all meshing member join as members. So I'm gonna delete all this to stay only with concrete structure member panel, and click OK. So it's okay. This is a beautiful model we have. So I can add some I can add some supporting, and there I put some supporting, and here. Okay, after I can apply some loads. I apply some load of my model, my complex model. As you can see, it's very complex. So what can I do for the next? It's just the first did model. I don't want to change the category, the subnature, etc, etc. And second did model, and after just a live model. Maybe for this I'm going to make some special. I'm going to try to make some wine simulation, and the second did load this did live, the first. Okay, I apply the same way, the same value. I select my panel, apply the thickly, yeah, and after I'm applying surface for the did. I put 1 kilopascal. Okay. Okay, the live loads I apply, I put 1, 2, 2, apply. Already finished for we have all. But by the way, for this this type of hyperboloid paraboloid form, we're gonna go behind, because we have maybe 10 meters of high. It's changing, so we're gonna make another things is to try to make some wind simulation. Load wind, generate wind simulation. Here we're gonna generate wind simulation, put here for all these regions. and determine the velocity. I put a 40 meters per second, the third level from 0, and apply a start my simulation. It can take several time because it's a complex shape model. So imagine to do all this in using hands calculation, how errors and time it can take to you, and time consuming to finish this work. For several months, the work, if you use the computer method, you can just take some few years, 1 year, 2 years, and finish your job. So this is some simulation of the wind. This is the first direction. Yeah, the direction is of the wind is for this. You see, this is the direction that where the wind load is applied on our curve shell structure of form. Always the simulations, it can take some time. So you can see here the wind compatibility, the value of load it apply on our surface, the load apply on particular positions for vertical positions, and the simulation time, and the load generations, and so and so. And here you can see the direction of our wind apply for the xy plus 1, the value of the loaded wind loaded apply on our different surface, and his behavior and the maps. It's beautiful to see how a numerical method can help us to quickly reduce error and to be fast for the structural design analysis of such as a structure as a shell structure. But if imagine you did all this analyze and works in using just hand calculation, imagine how time it can consume and errors you can doing. It's the reason why you must always using the numerical, the compute method, a finite element method to quickly working and make beautiful and amazing and trust work. It's very important. So I try to show all this method. It allow you to, as structural engineers, or if you are students, to see what you are doing if you finish your studies, your graduation. So it's time to learn how you can be more proficient and more professional for as a structural engineer. So after to load it, our model and make some loads, wind combination, wind apply loads, wind apply loads, and so after to calculation, so we can see some results about the map. I'm going to click here and the scale basics and go to, for example, to principal apply loads and see what happened. So this is one of us. The displacements you can see, and you can try to scale basics all already done. Apply, yeah, for our structure. So we can see for the tile principal, total or deformation, apply. And voila. And so this is the kinds of the information on our structure, and you can see more. You can start your simulations, see the mode of shape of the deformation of our structure, the behavior I always told from the beginning, see the the value of this max of the displacement, and so displacement and deformation of our structure. You can put simulations. You can do all you want here. You can start simulation and see the behavior of our deformation of our shape from this all load apply. You can see you can add it for representation and recording, and so this is what just a simple presentation I wanted to show about some tips you can using from AutoCAD. It's a behind the background. It's some height useful tips, a height of AutoCAD for civil structure. So if you're a civil structure, don't put down or don't lay it using AutoCAD, but I show you how AutoCAD 3D can be very useful and benefit for your works to time saving and be fast and quickly for structural modeling. Thank you so much. So I can find you for the next tip session. Who knows, maybe I can talk about other topics, maybe for civil infrastructures or civil structure only, or bridge design, who knows. So thank you so much. Don't forget to subscribe to be noticed and be updated for our new features in using AutoCAD or civil robot structural analysis tips to be more proficient and professional for your daily work. Thank you.